Hi, my name is Claudia, and today we're going to learn about acid and base. Properties of acid and base. Acids are proton donors or electron pair acceptors, wherein bases are proton acceptor and electron pair donors. Acids are able to increase H ion concentration in an aqueous solution, and bases are able to increase the hydroxide ion concentration in an aqueous solution. Acids have pH value lower than 7, wherein bases have a pH value more than 7. Acid turn blue and red litmus paper into red. Base turn red and blue litmus paper into blue. Acid reacts with base to form salts in an aqueous medium. Acids taste sour and bases taste soapy. Definition of acid and base. Svante Arrhenius. Arrhenius acids and bases. Acid is a substance that produces H ion when dissolved in water. For example, HCl yields hydrogen ion and chlorine ion. In this case, HCl is acid. Base is a substance that produces OH ion when dissolved in water. For example, NaOH yields sodium ion and hydroxide ion. In this case, sodium hydroxide is base. Johannes Bronsted and Thomas Lowry creates Bronsted-Lowry acids and bases theory, wherein acid is a substance that donates protons and base is a substance that accepts protons. For example, HCl plus water yields hydronium ion and chlorine ion. In this case, HCl that donates proton is acid, and water that accepts a proton is base. Gilbert and Lewis makes Lewis acid and bases theory. Acid is a substance that accepts electron, and base is a substance that donates electron. Here we have an example of ammonia, where ammonia has extra pair of electrons that forms covalent bond with the hydrogen ion. In this case, the hydrogen ion that accepts electron is the acid, and the ammonia that gives off electron pair is base. Chemical reactions that involve acids and bases. Reaction of acid with a reactive metal. Metal plus acid yields salt and hydrogen gas. Example, magnesium ion plus sulfuric acid yields magnesium sulfate plus hydrogen gas. Reaction of acid with carbonates. Carbonate plus acid yields salt, water, and carbon dioxide. For example, CaCO3 yields 2 plus HCl yields CCl2, water, and carbon dioxide. Reaction of acid with bicarbonate. Bicarbonate plus acid yields salt, water, and carbon dioxide. For example, NaHCO3 plus HCl yields NaCl plus H2O and CO2. Reaction of acid with metallic oxide. Metallic oxide plus acid yields salt and water. Example, ZnO plus H2SO4 yields ZnSO4 plus H2O. Reaction of acid with metallic hydroxide. Metallic hydroxide plus acid yields salt and water. For example, ZnOH2 plus 2HNO3 yields ZnNO3 2 plus 2HO2. This is the reaction that is balanced. Neutralization reaction. Acid plus base yields salt plus water. For example, we have HCl plus NaOH yields NaCl plus H2O. Reaction of base with ammonium salt. Ammonium salt plus base yields salt, water, and ammonia gas. For example, CaOH2 plus 2 NH4Cl yields CaCl2 plus 2H2O plus 2NH3. In this case, the equation is balanced. Reaction of base with a metal salt. Salt type 1 plus base yields salt type 2 plus metallic hydroxide. For example, FeSO4 plus NaOH yields Na2SO4 plus FeOH2. Practice question. Here we have K2CO3 plus HNO3. In this case, it is carbonate plus water, which yields salt. KNO3 plus H2O plus CO2. And we need to balance the equation. So we have 2K and 2H. Next, Li lithium phosphate plus calcium hydroxide yields. In this case, it is salt plus base, so we have salt type 2 plus Ca3PO42. Balance it all. And lastly, we have barium hydroxide plus ammonium sulfate yields. So we have ammonia gas, salt, and water. Balance it all. And lastly we have silver plus HBrO3. Now, since silver cannot react with acid, so there is no reaction. Chemical calculations involving acids and bases. Number of replaceable ions is total number of positive or negative charge of the ions that compose a compound. For example, HCl. Now HCl has charge of H has charge of positive 1 and Cl negative 1. So 1 times 1, 1. LOH3, Al, aluminium has charge of positive 3 and hydroxide has charge of negative 1. 3 times 1, 3 EQ per mole. Sulfuric acid, H has charge of positive 1 and SO4 charge of negative 2. 2 times 1, 2 EQ per mole. And magnesium phosphate. Magnesium has charge of 2 plus and phosphate has charge of negative 3. 3 times 2, 6 EQ per mole. Equivalent mass is the ratio between the relative mass of a given substance and its number of replaceable ions. EQM is equal to MR divided by number of replaceable ions, where the unit is grams per mole, grams per EQ after the mole has been cancelled. Here's an example of calcium nitrate. So firstly, we have to find the molar mass. Which is 164 grams per mole. And since the number of replaceable ions is 2, we need to divide it by 2 and we get 82 grams per EQ. Number of equivalents is the ratio between the given mass of a substance and its equivalent mass. Here's an example, 20.5 gram of barium hydroxide. Firstly, we have to find the molar mass. Which is 171 grams per mole. And we divide it by 2 to get the equivalent mass. Since we have exact numbers, so we round it off into 86 EQ per mole. And 20.5 divided by the equivalent mass. And since there's 3 significant figures, so we'll have 0.238 EQ. Practice question. Aluminum sulfate. Aluminum sulfate. Aluminum has charge of 3 plus and sulfate has charge of 2 minus, so we have 6 EQ per mole. Lithium hydroxide. Lithium has charge of positive 1 and hydroxide negative 1, so we have 1 EQ per mole. Percarbonic acid, which is H2CO3, H2CO3, so H has charge of positive 1 and CO3 has charge of negative 2. So it's 2 EQ per mole. Next, 80.0 grams of sulfuric acid. If we want to find the EQ equivalent mass, we need to find the molar mass. Which is 98 divided by 2 to get the equivalent mass, which is 49 EQ per mole. 0.0 grams over 49. Is equal to 1.63 EQ. Next, 2.00 grams of magnesium hydroxide. need to find the molar mass. (58 grams per mole divided by 2 is equal to 29 EQ per mole, and 2.00 divided by 29 is equal to 0.0690 EQ. Normality. Normality is the number of equivalents of solute divided by liters of a solution. N is equal to NOEQ solution divided by V in liters. So the unit is EQ per liter. Calculating normality in terms of the substance's concentration, which is molarity. Molarity is the mole of solute divided by liter of solution, with the unit of mole per liters. Derivation of normality equals to number of EQ solution divided by volume of solution, and not number of equivalent of solute divided by volume in solution. So here we have number of equivalent over V is equal to mass divided by molar mass over number of replaceable ion over liter is equal to mass divided by mass over mole over number of replaceable ion divided by liter equals to, so mass cancel with each other, so we have mole times number of replaceable ion over liter. So mole per liter is equal to molarity times number of replaceable ion is equal to normality. So here we have an example: 500.0 milliliters solution made by dissolving 200.0 grams of sulfuric acid in water. What is the normality? So here we have 500.0 milli. So we need to make grams 200.0 grams over molar mass, which is 98. So mole per liter 0.5 times 2 is equal to 8.163 N. Calculation involving neutralization reaction. Neutralization reaction is the reaction of an acid and base to produce a salt and water. In neutralization reaction, the number of equivalents of an acid is equal to the number of equivalents of a base. Now, since we have molarity equals to number of equivalents over liter, so number of equivalents is equal to normality times the volume. So since we have number of equivalents of acid equals to the number of equivalents base, so normality of acid times the volume of acid is equal to normality of base times volume of base. There's an example here: how many milliliters of HCl, which they're asking volume of acid. If the normality of acid is equal to 1.52 N, they will react completely with normality of base 3.12 N of potassium hydroxide with a volume of 60.0 milliliters. So we have NaVa equals to NbVp. So 1.52 Va is equal to 3.12 times 60.0. Va is equal to. Now, since we have all three significant figures, so we're going to make it 123 milliliters. Titration. Titration is the process of adding slowly a solution of unknown concentration called titrant or standardized solution to a certain amount of another solution with unknown concentration called titrant or analyte until a complete neutralization reaction takes place. Indicator is a specific substance that exhibits a specific color when the neutralization is complete. Endpoint or equivalence point is the point at which an acid and a base have neutralized. There's an example here. A 50.0 milli sample of hydrochloric acid is titrated with 60.0 milliliters of a 2.40 molarity sodium hydroxide. Find the molarity of the acid solution. So here we have Va, Vb, and Nb. So we're going to find the Na. Na times 50.0 milli is equal to 2.40 times 60.0. Na, since we all have three significant figures, so Na is 2.88 N. 2.88 N is equal to molarity times number of replaceable ions. Number of replaceable ions of the hydrochloric acid is 1. So in this case, molarity is equal to 2.88. Practice question. A sample of 60.0 milliliters solution of potassium hydroxide in water can be neutralized completely by 40.0 milli of 1.05 sulfuric acid solution. How much is the concentration of sulfuric acid solution? So we're looking for molarity of sulfuric acid and the normality of potassium hydroxide. And lastly, we're looking for molarity of potassium hydroxide solution. So here we have Vb, Va, and Na. What we need to find is the Nb. So 1.05 times 40.0 is equal to Nb times 60.0. Nb is equal to 0.70. 0.700 as its three significant figures. And here we have the normality of potassium hydroxide. Next, the molarity of sulfuric acid. So here we have 1.05 as normality of sulfuric acid is equal to molarity times 2 as number of replaceable ions. So molarity is equal to 0.525 mole per liter. And lastly, molarity of potassium hydroxide. We have the normality of potassium hydroxide as 0.700 is equal to molarity times 1. So the molarity is 0.700 mole per liter. Another practice question. 10.0 milliliters sample of sodium hydroxide solution is titrated with 0.600 N hydrochloric acid solution. If 20.0 milliliters of hydrochloric acid solution is used to reach equivalence point, what is the normality of sodium hydroxide solution? How much is the concentration of sodium hydroxide solution? So we're looking for the molarity. Okay, here we have Vb, Nb, and Va. 0.600 is an Na. So we're looking for Nb. 0.600 times 20.0 is equal to Nb times 10.0. So Nb is equal to 1.20 N. And as 1.20 N is equal to the normality, then normality is equal to molarity times 1. So the molarity is also 1.20 mole per liter. Percent acidity. Percent acidity is the percentage of acidity in terms of the ratio between the mass of acid solute and the mass of acid solution. Percent acidity has the formula of mass of solution and mass of solute over mass of solution times 100%. In a very diluted aqueous solution of acid, the density of the solution is approximately the density of water. And here we have the example. A sample of 15.0 milliliters of vinegar is titrated against 0.100 N of sodium hydroxide solution. If the amount of sodium hydroxide solution used is 125 milliliters, what is the mass of acetic acid in vinegar? And what is the percent acidity of the vinegar? So here we have Va, Nb, and Vb. So we're going to find Na. Na times 15.0 is equal to 0.100 times 125. Na is equal to 0.833 N. 0.833 N is equal to number of equivalent mass. In this case, we're going to use moles times number of replaceable ions. So molarity times number of replaceable ions. Molarity is equal to 0.833. So molarity is equal to moles per liter. So grams over molar mass of CH3COOH, which is 60 over liters, 0.015. So here we have the mass equal to here we have three significant figures, so we're going to round it up into 0.750 grams. For the percent acidity, we're going to use the mass 0.750 over the mass of solution times 100%. Now, we don't have the mass of solution, but in a very diluted aqueous solution of acid, the density of the solution is approximately the density of water. So we have 1 grams per milli as the density of solution. Density is equal to mass over volume, and the volume of the solution is 15.0 milli. So the mass is equal to 15.0 grams. So we're going to make 0.750 over 15.0 times 100% equals to 5.00%, since there's three significant figures. pH and pOH. pH is the power of hydrogen and pOH is the power of hydroxide. pH plus pOH is equal to 14. The pH of a solution is a measure of the acidity of a solution. This measure of acidity was proposed by Søren Sørensen in 1909. In contrast, pOH is a measure of the basicity. The pH power of the base 10 is equivalent to the reciprocal of hydrogen ion concentration. So the pH power base of 10 raised to pH, is equal to 1 over concentration of hydrogen ion. So if we log 10 the 10, we have pH is equal to log 10 of 1 over concentration of hydrogen ion. So pH is equal to log hydrogen ion raised to -1, which means negative log of hydrogen ion concentration is equal to pH, same as pOH. pOH is equal to negative log of hydroxide ion. Here's an example. A solution of hydrochloric acid has a concentration of 0.0215 m molarity. Find the pH, pOH, and hydroxide ion concentration. So, HCl, we have the hydrogen ion concentration of 0.0215. So, negative log 0.0215 is equal to 1.66. So negative log 0.0215 is equal to 1.67 as the pH. And pOH is equal to 14 minus 1.67, which is equal to 12.33. And as we have 10 raised to pOH is equal to 1 over concentration of hydroxide ion. So concentration of hydroxide ion is 4.677 times 10 raised to -13 molarity. Conjugate acids and conjugate bases. Conjugate acid is the chemical compound formed by the reception of a proton by a base. Conjugate base is the leftover after an acid has donated proton using a chemical reaction. So here we have H2PO3 with the charge of -1. So if we want to have the conjugate acid, we add 1 hydrogen ion into it. So we have H3PO4. And for a conjugate base, we need to remove 1 hydrogen ion, so it's HPO4 2-. And for SO4 with a charge of 2-, we can have conjugate acid by adding hydrogen, so we have HSO4 with a charge of -1. And for this, we don't have conjugate base because there's no hydrogen in it. And here we have another one, HNO2 plus H2O reverse yield equal to NO2 with a charge of -1 plus hydronium ion. So here we have HNO2 giving off its hydrogen. So this is a proton donor, which is acid. And water in this case accepts hydrogen from the acid, which is the base. And NO2 minus, as it doesn't have it is the leftover after the acid gives off its hydrogen ion, so it's conjugate base. And hydronium ion, after it receives hydrogen ion, it became the conjugate acid of the base, conjugate acid of H2O. And practice question. We have HF plus H2O yields F minus plus hydronium ion. So I have fluorine ion as the conjugate base after HF gives off its hydrogen ion, and H3O as conjugate acid after it receives hydrogen ion. Next question. The pH of a 0.500 liters base solution is 4.15. What is the pH of the solution? Hydrogen ion concentration, hydroxide ion concentration, and how many moles of the base solute is present in the solution. So we have the pH of 4.15. So pH is 14 minus 4.15 equals to 9.85. And as 10 raised to 9.85, we have 1 over hydrogen ion concentration. So hydrogen ion concentration is equal to 1.41 times 10 raised to -10. Hydroxide ion, we have 10 raised to 4.15 is equal to 1 over concentration of hydroxide ion. So the hydroxide ion is equal to 7.08 times 10 raised to -5 molarity. And lastly, for the base, the mole of base, we have 7.08 10 raised to -5 molarity, which is mole per liter, times the liter of base, 0.500. And we'll have 3.54 times 10 raised to -5 mole. That's it for the lecture. Thank you for watching.